Next, we're going to learn about SN2 mechanism. Basically, SN2 ni ialah bimolecular nucleophilic substitution. The term bimolecular tu maksudnya both haloalkane dengan nucleophile tu akan involve in the rate determining step. That's why it's a one-step reaction. Okay, maksudnya the process of bond breaking dengan bond formation ni will occur simultaneously, and this reaction is actually a second order reaction. Dengan rate law for second order reaction for this mechanism is rate law dia is equals to rate constant kalikan dengan concentration of haloalkane kalikan dengan concentration of nucleophile. The intermediate species yang dihasilkan ialah activated complex. Kat sini dia nak bagi tahu kita akan guna stronger nucleophile. Kita tak guna weak nucleophile. So the stronger the nucleophile, the higher the rate of reaction. Okay. And bila you nak buat nucleophilic attacks tu, you akan attack at the opposite of the halogen to minimize the repulsion. Okay guys, next, SN2 reactions depends mainly on steric factors. Steric factors tu maksudnya dia berkait rapat dengan bulky effect. Bulky ni something yang besar kan? Okay, contohnya lah, these two haloalkane, actually a primary haloalkane. How do you know? You look at this carbon yang attached directly pada halogen. Okay, these two carbon atoms yang attached directly pada halogen atom, both of them is a primary carbon. How do you know? You tengok carbon ni, dia attached pada satu je kan carbon. Okay, therefore, that two haloalkanes is a primary haloalkanes. Itulah primary haloalkanes. Okay, should be in nature. Primary haloalkanes ni semua kena undergoes SN2 mechanism. Tapi dia ada exception because of steric effect. Because why? Okay, kalau let's say if you look at this haloalkane, although that dia primary haloalkane, you tengoklah dia attach pada large alkyl group. Besar sangat kan, serabut. So what kind of alkyl group is this? Dia ada 1, 2, 3, 4 carbon. This carbon ialah carbon tertiary. I believe that this is actually a third butyl. Okay, this is third butyl. Because dia ada 4 carbon and carbon yang attached to carbon tertiary. So this is actually a huge alkyl group. Okay, so since that dia ada high steric effect, dia tak akan buat SN2, dia akan buat SN1. Okay, for this haloalkane, dia tak serabut lah, dia walaupun dia attach pada satu saja carbon, carbon ni carbon methyl je. Okay, this is only a methyl carbon, so dia tak serabut. That's why bila dia tak serabut, dia ada low steric effect. Bila dia ada low steric effect, makanya dia akan undergoes SN2. Kiranya steric effect ni dia tak akan favor, dia will not favor, tak favor SN2. Okay, kiranya the larger the steric effect, lagilah dia akan buat SN1. Alright, so let's start with SN2 mechanism. So basically SN2 mechanism is a one-step mechanism. So this whole thing is actually SN2 mechanism and it is one-step mechanism. Alright, so you need to always show the mechanism in three-dimensional structure and kena in tetrahedral. So this one, they actually mention about how you draw your haloalkane. It must be 3D structure and must be tetrahedral. And then it will involve the formation of transition state. This is transition state, which is the intermediate. This is what we know as activated complex. Kenal tak pasal ni, activated complex ni? We have learned this before, right? Pasal activated complex. Okay, so let's start the mechanism with the nucleophilic attack. And this is your haloalkane. So you kena draw your haloalkane dalam bentuk 3D structure. Okay, wedges bond, hatches bond. Okay, and then lukis dia dalam bentuk macam terbalik, macam ni. Dalam bentuk macam payung terbalik, payung inverted. So what happened here? The nucleophile will attack the carbon atom from the backside to minimize the repulsion. And next, You kena show arrow to show that the bond between carbon dengan X ni dia akan buat bond breaking. Okay, so that is a slow process. Because of this, dia akan menghasilkan intermediate activated complex, or we call it as transition state. Transition state, simbol untuk transition state ialah this. Okay, and then bila you nak lukis the activated complex, it must be in this bracket. Okay, so actually this whole thing ialah activated complex. Okay, the way you want to draw the 3D structure at transition state, okay, you have to draw it macam dalam bentuk trigonal bipyramidal. Okay, bukan tetrahedral dah, trigonal bipyramidal. Therefore, you kena kepakkan these wedges dengan hedges bond. Tak boleh buat dekat-dekat macam ni, kena kepakkan dia. Yang ni yes, you kena buat dekat-dekat. Yang ni no, you kena buat jauh sikit to show the structure of trigonal bipyramidal. Okay, so actually there's a huge difference between these wedges dengan hedges bond and also this bond. Okay, this bond is actually quite temporary. Okay, kenapa dia temporary? Because actually dia nucleophile ni macam dia nak melekat dekat carbon. Carbon ni pula dia nak buat bond breaking dengan halogen. So that's why this is a temporary bond. The way you draw this temporary bond mestilah strictly dash line macam ni. Okay, this is not the bond hedges ataupun wedges. So this is actually a fast process. Next ialah fast process is when you dah lekatkan nucleophile to your carbon atom and this halogen dia dah left this carbon atom and dia akan dapat charge negative. Okay, so after that you need to draw dia punya product dalam bentuk inverted. Nak show macam okay, bila dia attack dia macam terkedepan bond dia, macam tu, dia terkedepan bond dia macam ni. Alright, because of the nucleophilic attack. Okay, so let's do SN2 mechanism for this chemical reaction, where this chemical reaction ialah hydrolysis of haloalkane, di mana haloalkane dia akan react dengan nucleophile yang akan dapat alcohol as the product. Okay, but in this case we know that dia akan undergo SN2 mechanism just because dia gunakan strong nucleophile and also this is a primary haloalkane. Okay, so kalau primary haloalkane memang sah-sah dia buat. Kalau dia tak ada steric factor, dia memang sah-sah akan buat SN2 mechanism just because kalau SN1 mechanism kan perlukan kamu untuk buat carbocation ion. Kalau carbocation ion, you kena form the stable carbocation ion lah. So, since that this is the primary haloalkane, so dia tak ada pressure pun untuk form the stable carbocation ion. Okay, so that's why dia terus buat SN2 mechanism. Tapi kalau SN2 mechanism, it's a one-step mechanism. So, bila you nak buat SN2 mechanism, we have seen from the previous slides, we can see that your haloalkane needs to be drawn in a 3D formula structure. Lepas tu bentuk tetrahedral. Do you know syarat-syarat bentuk molekul tu jadi tetrahedral tu apa? Syarat dia, the carbon must be sp3 carbon. Okay, carbon sp3 tu pula apa? Carbon sp3 ni is when this carbon dia ada 4 sigma bond around it. Okay, 1, 2, 3, 4. Okay, I know that bila you nak condensekan this molecule, you actually will get a CH3, CH2, Cl. Okay, so you must be wondering macam mana, where do I start? Should I start it from CH3 nak lukis the tetrahedral? No, you should find the carbon yang closest to the halogen. For example, this carbon is the carbon that is closest to the halogen. So this carbon you kena susun dia bila, dalam yang membuatkan dia ada 4 sigma bond around it. So nanti you senang lah. This will be the first group, second group, third group, fourth group. Okay. yang you akan letak dekat tetrahedral 3D structure. And this is not enantiomer, bukan enantiomer langsung. This is how you should draw the mechanism. Okay, the haloalkane needs to be in 3D tetrahedral structure. Kalau enantiomer, yelah kena chiral carbon. This one you don't have to make it chiral carbon. You kena make sure you susun dia carbon yang closest to the halogen tu, you susun dia yang membuatkan dia ada 4 single covalent bond ataupun 4 sigma bond around it. And after that, you lukislah tetrahedral structure untuk carbon sp3 macam mana. So bentuk tetrahedral ni kan, bentuk dia macam tripod stand, tak pun macam microphone stand. Okay, bentuk dia macam tu. So, sekarang ni you bolehlah letak any atoms ataupun molecules as you wish. So, for example, I nak letak kat sini CH3 lah. This will be Cl. This will be hydrogen and hydrogen. Okay, so make sure you kena susun dalam bentuk macam ni juga. What happen if let's say you tak susun dalam bentuk macam ni, you akan fikir, mana aku nak letak ni, CH3, CH2, should I put 3H here, should I put, okay, so you kena remember bila you nak draw the 3D structure tetrahedral of your haloalkane, you have to start it from the carbon that is nearest to the halogen, and then you make sure this carbon kena ada 4. You kena highlightkan 4 covalent bond around this carbon. Okay, sangat-sangat penting tu. So next step barulah kita, after you dah lukis you punya 3D shape of your haloalkane, barulah kita proceed dengan buat mechanism SN2 for your haloalkane. So you have to draw it. Kalau ini you buat menegak kan, tapi you kena draw melintang, horizontal like this. Tapi dia kena spesifik lah, kena macam ni. Memang kena macam ni. As if bentuk dia tu actually bentuk dia macam ni. You tak boleh buat dia kangkang sini ke, kangkang atas sana ke, nope. Kena spesifik macam ni. Ikut bentuk shape tu memang kena macam ni. Okay, dash bond kena dekat-dekat dengan wedges bond, and then dia macam duduk bersimpuh macam ni berdua, macam tu. Okay, I don't want you to draw it kangkang lain macam. Memang kena buat betul-betul macam ni. Cumanya kalau let's say you nak tukar any atoms or molecules here, ikut suka you lah. Tapi kena make sure betul-betul macam ni you dapat. You have to draw it as if you got this kind of form correctly. Okay, so although there is a one-step mechanism, the mechanism starts with the nucleophilic attack at the backside of this haloalkane to minimize the repulsion, right? So since that this is a strong nucleophile, so senang dia nak dissociate. Jadi Na plus dengan OH minus. So you kena remember there's a difference between strong nucleophile dengan weak nucleophile. Kalau weak nucleophile, you akan buat nucleophilic attack daripada lone pair. Kalau strong nucleophile, you akan buat nucleophilic attack daripada negative charge. Okay, kerana strong nucleophile dia terus menjelma di dalam bentuk anion macam ni. Okay, you terus dissociatekan dia dengan metal. Okay, so dia akan buat nucleophilic attack. This nucleophile akan buat nucleophilic attack from backwards to minimize the repulsion. And then this carbon dia akan break dengan Cl. You need to show that carbon ni akan break dengan Cl. Okay, so after that it's a slow process and you will form this reaction intermediate. This is what we call it as activated complex. Okay, so you kena draw it as like bentuk dia bentuk trigonal by pyramidal. You kena dapat this shape correctly. Okay, you salin lah macam mana Miss buat ni, you salin. So it is as if this carbon you buat bentuk segitiga dulu, lepas tu straight line macam tu. Okay, so if you tak nampak, Miss buatlah bentuk trigonal by pyramidal macam mana. Kali ni wedges dengan hash bond dia terkangkang luas. So you buat macam ni. Jangan rapatkan dia punya ni. Rapatkan hash bond dengan wedges bond. Buat je macam ni. Okay, cumanya kenapa dia ada, kalau let's say kat sini kan, between OH dengan Cl ni, dia ada dash bond kat situ. Kenapa ada dash bond instead of bond yang memang straight ke ataupun wedges or hedges bond? Kenapa dia dash bond? Because this dash bond is actually a temporary bond. Kiranya nak tunjuk kat sini, OH ni dia akan melekat pada carbon. Nantilah dia akan you punya final product OH ni akan melekat pada carbon, and carbon ni dia akan buat bond breaking. This one akan buat bond formation, this one akan buat bond breaking. So that's why dia buat dash line ni untuk temporary punya bond. Nak show this is a temporary bond. But then since that this is a transition state, you kena buat this activated complex di dalam bracket tajam macam ni. Lepas tu you kena mention that this is a transition state. This is the symbol for the transition state. Tulis juga yang this one. After that is a fast process. It's a fast process when OH ni melekat pada carbon. Okay. And then Cl ni dia akan berpisah daripada this carbon. Okay. So you akan dapatlah side product Cl minus. And then you nampak tak bentuk dia jadi inverted. Bukan jadi macam ni dah. Dia inverted ke belah sana. So I want you to please get this shape right. Okay, you nak lukis tetrahedral ni, please lukis dia macam ni juga. Okay, it is as if bentuk dia macam ni. Nampak tak? Dia start dengan bentuk yang macam ni. Okay, start with this kind of shape of your tetrahedral 3D formula structure. Lepas tu kat tengah-tengah, in the middle, you got this kind of shape, trigonal bipyramidal. But then you have to make sure this bond at the middle is a temporary bond, so you kena lukis dash line. And the last one is this shape. Okay, dia inverted. Dia macam you ingat lah, dia attack, lepas tu dia macam terkejut, dia ke belakang semua, macam ni contohnya lah. Okay, so I want you to get the shape right. Alright, so let's try this out. Dia suruh kamu show the mechanism for this kind of reaction. This is actually hydrolysis of haloalkane because you form alcohol as the product. So untuk mechanism for haloalkane, we have studied that there are actually how many of them? There are two mechanisms for haloalkane, which is SN1 dengan SN2, but then both of them will depend on the class of the haloalkane and also the strength of the nucleophile. Alright, so if you look at this reaction, okay, if you look at this haloalkane, what is the class for this haloalkane? It's a secondary haloalkane. Because why? Because this carbon is a secondary carbon, because this carbon is bonded to another two alkyl groups, while this nucleophile, because dia terus ada negative charge, that means this is a strong nucleophile. Okay, it's a strong nucleophile. So, kalau secondary haloalkane, dia akan depends pada strength of nucleophile. Kalau dia buat dengan strong nucleophile, that means dia akan undergo SN2 reaction. SN2 mechanism. Okay, untuk SN2 mechanism is a one-step mechanism. Again, although that you have this kind of 3D formula structure yang menegak macam ni, vertical like this, but then when you want to do the SN2 mechanism, you have to make it the tetrahedral shape 3D formula structure to horizontally. Okay, so this is how it looks like. I want you to get the shape right, please. Ataupun kalau you tengok Miss punya contoh previously, you kena get this kind of shape, okay? And then tak kisahlah wedges dengan hedges bond ni, dia wedges bond ke atas ke, hedges bond kat bawah ke, it doesn't matter, but then you kena draw the wedges dengan hedges bond tu dekat-dekat dengan each other like this. Okay, so since that your nucleophile here is already ada minus sign, ada negative charge kat atas ni, so teruslah buat nucleophilic attack daripada OH minus. Dia akan attack backwards dekat carbon yang directly bonded to this halogen atom, backwards. Okay, because dia nak reduce repulsion, and after that this carbon dia akan break the bond dengan Br. Okay, so it's a slow process. where you will get this kind of activated complex. Okay, activated complex should be drawn like the shape of trigonal bipyramidal. Okay, where kat tengah-tengah ni is a temporary bond. So excuse me, this is temporary bond. So it should be dash line. So betul kan? This one buat dash line. And also yang H ni sepatutnya straight, bukan menyengit macam ni. Okay, so buatlah straight like this. Okay, so it should be bentuk dia macam trigonal bipyramidal. So this is your activated complex. Where kat sini dia nak show lah, kita akan buat bond formation of OH dan juga carbon, and also bond breaking between carbon and also Br. So this is what we call as activated complex, or as known as transition state. So please labelkan transition state, the symbol here don't forget, and also the bracket tajam ni. And next is a fast process when you really buat the bond breaking and bond formation. Okay, where you will get this. Okay, you tengok sini, kat sini terhasillah bond between OH and also carbon, and also Br ni dia akan jadi side product, which is pluskan dengan Br minus. Okay, but if you look here, dekat final product tu, dia punya bentuk tetrahedral berbeza pula bentuk dia macam ni. So please get bentuk yang correct. Okay, so that's all for SN1 and SN2 mechanism. Thank you for listening.